Hi, folks. Welcome. We're going to spend about an hour or so, maybe more, maybe less, diving into Isograph from the perspective of a user. So in this case, what that means is if you are using Isograph and you make a change, it's going to generate a bunch of files. I want you to understand like why those files are generated and how to think about that, and then sort of understand how those files get turned into the code or sort of the network requests that you use at runtime to give your app the performance that you want, and so on and so forth. So before we do that, let's like talk a little bit conceptually about what a website is. So we're all familiar sort of with, let me see if I can make a third one. Yeah, there we go. That's a little easier to see now. With like what a website is. So on the one hand, we can think of a React website or React app as sort of a tree of React components. So we might have a blog container, which contains a blog header, which contains a blog body. With blog container, which contains a header and also contains a blog body. Excuse me. This is fine, and it's actually really easy to go from a design that a designer gives you to a tree of components, and this is a pretty good developer experience. Okay. Now, each of these components is going to require some data. So, for example, the blog container component might need the ID, the blog header component might need the title, and the blog body might need the body. So we don't really want to make separate network requests in each of these React components, because then we'd have some sort of network waterfalls. Like we wouldn't be able to render the header and the body before the blog containers component, the blog container component's network request resolves. I guess just for, maybe it needs something else. Maybe because like ID we obviously have from the URL. So other thing. We'll just call it other thing. Okay. So one thing we usually do is we, at the root, make a single network request for all the data needed by a given page. So for example, we might have this blog data root, and then, okay, we'll get rid of other things. That was just for simplicity. And then each of these guys, each of these components, well, all the data that is requested by a subcomponent, is needed by a subcomponent, becomes part of that blog data root. Actually, maybe we can just rename blog data root something like blog query. Huh? Okay. Okay, cool. All right. So if we have this blog query, it fetches all the data, and then, whatever, somehow everything else gets the data. That's one thing. I think this is a little bit confusing. So instead, it's a little bit easier to think about this as if there was a separate entry point, and the blog container component was something that was underneath the entry point. So if we do this, okay, so now we have this blog entry point, which fetches the query and also starts to render like this subtree. So this is sort of what I imagine a React app really looks like. So there's one tree that we're really thinking of, which is the component tree. But there's also this separate tree that is sort of next to it, which is the data tree. Like it would be a lot more complicated than this. Some of the subcomponents would overlap with what they fetched. And other stuff, like this is, obviously it just looks like two parallel trees in this specific example, but like in practice, like this would be a lot more complicated. And what you're sort of imagining here is that, okay, so if we add something, if we add a component to the, add a piece of data to the blog body, for example, if we maybe have like email, right? Well, we also want to add it to the blog query, right? So the blog query should also have email, right? Okay, this is really weird how it keeps animating, but whatever. And the problem with this world is that that's a lot of changes for a single user to make as they're editing the blog body. So for example, we might be editing the blog body and we decide, we don't need the email anymore. So you look at the blog body component and you stop selecting the email. Well, what happens? Now this blog query is selecting the email field, but it doesn't need the email field because nobody ends up using it, right? So hence, what we need to do is to sort of generate the query for a given tree at compile time. That's like conceptually what Isograph is doing. It looks at your blog container, it looks at your blog entry point and like sort of traverses all of the components and looks at all the fields that they use, and then it sort of generates everything underneath blog query. And so obviously as a result of that, it would maybe just like, wow, this is really slow. Wow, okay. You know what? It'll get there. It'll get there. There we go. Okay, so it won't do email. It just looks at this and it just won't do email. Okay, let me see if I can clear this guy out. Okay. This is my first time playing with GraphViz, so it's kind of fun. Okay. So one thing we discovered is that adding and removing fields from a blog body component or from like a subcomponent affects the blog query. And so that's at least two places that you need to update if you are a user, if you are a product developer. Now, one of the things we want to optimize for is that the product developer can look at one file, make the changes that they want, and then sort of move on with their life, rather than have to change a bunch of things. Okay, you might say, well, editing the blog body and editing the blog query, okay, that's like not that hard. Like, what's the big deal? Well, the answer is, what if the blog container component, well, one thing is like, what if the blog container component fetch the email, right? Well, then this is no longer red. Now it should be, now we actually need to fetch it from there. So if you remove it from one field, maybe you need to remove it from the query, maybe not. That's like kind of a lot of work to reason about. And the other thing is that, okay, so let's get rid of email because that's just going to make this more complicated for no reason. Okay. Oops, I don't know if I can because it's slow. Okay, so pretending email doesn't exist. The other thing that might happen is that we don't just have a single blog query for all of the stuff. What if blog body component was its own entry point? So like let's say we really want to render the container and the header, but the blog body, like it might take a long time to render, to fetch that data. So we want to sort of defer it in GraphQL terms. So we might structure that as something like, I guess, blog container, blog body, oopsies, entry point, and then blog body entry point, blog body container component. Okay, that looks incorrect. Body component. Yeah, okay, there we go. Something like this. So now the blog query, well, it shouldn't contain the body, right? Because actually the blog body entry point contains a blog query too, and so now we have, what color do we have? Purple. Blog subquery to body, and we don't have that one. Okay, blog subquery and then blog body entry point, blog subquery, right? Okay, so now this is what the query should look like. Or I mean, what the whole structure of the app should look like. But remember, all we did to make a change between 1 and 2 was that we sort of deferred the blog body. Making this many changes manually is really, really fraught and not something that you actually want to have users do, but it's what they should do if they're building an app that's actually performant. And so I think as a result, most apps aren't performant as they could be, given the fact that it's just so much work to do that kind of stuff. And a lot of people would, I think, given the choice, defer a lot of components if they're not part of the initial paint, especially at companies that really, really care about time to first paint and stuff like that, because they're very, like, let's say, SEO driven. Okay, so, and then the last thing I want to talk about is, like, if this blog body entry point was deferred, right, and it used the body, but let's say the blog header uses the body. I mean, that doesn't really make too much sense, but it does. Who cares? Well, now that blog subquery doesn't need to fetch the body, right? Because it's already part of the parent query. And we are sort of guaranteed that the blog subquery is executed after the blog query, based on the structure of the graph. So at this point in time, the blog subquery should not contain the blog body. It should just be an empty query, so, like, not really, it should not be fetched, but, like, it, you know. Okay. So what we mean here, what this means is that, like, if the blog header starts to select the blog title, well, now we not only need to add it to the blog query, we also need to remove it from the blog subquery. That's like way too much for a user to be able to do in their head at once. Okay. This is only talking about data, but there's some analogous version of this where it's like the blog container, I don't know, the blog header. Where do we have blog header? Let's make a new section in, let's say orange. Orange is a good color. Like 15 seconds later, we'll get a color. Okay, so if maybe we have something like a blog header component, you know, header class, right? Okay, right? That's like some sort of CSS thing. And then we have, I mean, I don't know, like the fact that we have like CSS that's attached to this component is something that is like part of some sort of more advanced tree that we would want to do. Okay, so just right now, Isograph only deals with data and the JavaScript to render those components, but like eventually I want you to be able to embed CSS and chunks of CSS and stuff like that inside of the queries, because it's all kind of the same problem. The problem is what data or what do we load in a given state of the app, and let's try not to load more than we need, and let's definitely not load less than we need. And then let's also reflect changes. Let's also like recompile the tree of the app whenever something changes, because, you know, you don't, if you start selecting the header class from somewhere else, like it doesn't, you know what I mean. Okay. So anyway, ignoring CSS because that's not something that Isograph does right now. This is what we ended up with. Okay. I know this is super high level. Conceptually, does that make sense? Okay, I see a nod. That's good. Okay. Awesome. Okay, so now let's actually take a look at Isograph itself. Okay, so if we go to this one, okay, we take a look at Isograph, right? Here we have an Isograph app, which is just putting a bunch of logs to the console. And we take a look at some sort of component tree. So remember, this is the green arrows. And we look for at components. We see home route as a component. We see pet summary card as a component. We see favorite phrase loader as a component. We see another pet summary card, and so on and so forth. Okay, so actually let's click on one of these. Is it this one? oopsies, no, let's go back to click on the avatar. Not the world's most organized demo, but like if we take a look at this, we have detail route inner, pet check-in, this thing is a pet check-ins card. We have a bunch of check-in displays. Then we have some stats cards, best friend card, some sort of best friend updater, whatever. Okay, a bunch of components. It kind of is what you would expect. And you take a look at the network, and you see this whole thingy here. I guess we can look at this preview here, and we see all the data for a given page. So that's sort of equivalent to the blog query. We're not seeing, like, the generated artifact here is the blog query. We don't see like all the sub parts of that tree, but like those exist. Anyway, so this is like all the data we need for a given page. I think because there's only one query on this page. Okay, so let's take a look at how that actually looks. Let's save example and then get rid of it. Okay, so if we go to pet detail route, what we have here is, this is just a wrapper that I used to like demonstrate, to like test some sort of stuff, so it doesn't really matter. We can just pretend it's actually just pet detail route. Actually, let's go ahead and make that change. Instead of doing this, you can just do this. And then what we need to do is run the compiler. So what we're going to run is watch pet demo, which is the command to do it. Okay, unparsed tokens remaining. Looks like, oh yeah, I have this guy right here. I didn't copy and paste very well. Okay, has unused variables ID. Okay, that's because we called the actual ID here. ID, okay, awesome. Now it compiled. Okay, so now if we go back to this guy, it doesn't like hot module reloading. That's okay. I don't know if I actually care about that. Maybe I should. Okay, if we look at component, well, we just have pet detail route, and there's no pet detail route inner anymore. Okay, pretty simple change. Okay, so what are we doing here? We're making a network request for this pet detail route. And if we look for query.petDetailRoute, we have this entry point. Okay, so somewhere we have this entry point. This is a regular React component at this point in time. The Isograph compiler, when it runs, will look at your code base and find this entry point. And based on this entry point, it will sort of crawl the tree. And it will start at the pet detail route, and then from the pet detail route, it will look at the pet check-ins card and best friend card and blah, 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 and generate a query for all of the fields that are needed, that are accessible from that entry point. So the pet detail route entry point, that ends up going into query / pet detail route / entry point. And this guy will contain the query text for all of the data needed by a given page. So for example, if we do this, I can't do that. Let's try this again. There we go. So for example, if we start adding, let's find name here. Okay, name. Okay, let's see what happens if we remove name. Nothing happens, probably because one of the other components here use the name field. So let's take a look at pet schema. What is on pet? I don't actually remember what's on pet, but oh yeah, because it's expecting capitalization. All right, alt tagline. Okay, that's something that I probably haven't used. That's probably just pretty silly. Okay, if we do that, are we select? Oh, there it is, alt tagline. Okay, just took a second for it to show up. Okay, because one of the queries that is accessible from the entry point started selecting alt tagline, it shows up in the query, and so when we make that network request, we now get that data. Okay. That's how the query is generated. Basically, we start at the entry point, we fan out to all of the client fields, and we collect all of the server fields meaning something that's defined as part of the GraphQL schema, and generate a query for all of the server fields. Okay, so this thing will contain none of the client fields. So okay, so a client field is something like this. It's a isograph literal. So isograph literal just means ISO parentheses followed by backtick. This is guaranteed to be just a string, essentially. You're not allowed to interpolate anything, even though it's the backtick syntax. The Babel transform will throw an error if there's any interpolations here. And also probably the compiler will crash because it doesn't expect... well, maybe it won't. I don't know. Maybe it'll tell you that it's unable to parse it. I'm not sure. Okay. So this is a client field, and this is essentially a function from some graph data, which could be other client fields, it could be other server fields, to some sort of arbitrary value. So in this case, that arbitrary value is sort of this component right here, essentially. And we have this magic @component annotation here, which we'll talk about later. But like the point is that this is a React component here, and it takes essentially two parameters. So I don't know, runtime props. Let's just say runtime props is a thing with foo string. And the first parameter will contain the data, and then the variables, parameters. And then this parameters type is, we can jump to the definition, and we see that, well, the parameter type is this guy, and we see that it has an ID, which is a string. Some of the awesome work that Vadim just landed is to add types to that. So I'm super excited about that. So we get this, we get these passed to this function, and we also get some runtime props passed to this function. And then we can do whatever the heck we want with these. But in particular, this data type, that's sort of the most important thing that we're going to worry about. It is something that looks like this highlighted selection here. So for example, it's going to contain, like the pet field is going to contain a pet check-ins card, and it's going to contain a best friend card, and so on and so forth. So what do we do in this example? We check if the pet is null, and then here, inside of here, we'll get like pet.pet check-ins card, right? And we can just directly render that component. So we're not passing any data down. The data is sort of figured out by Isograph, and it is passed to that subcomponent via Isograph. So you don't have to do any of that. But we'll talk about how that actually works. Okay. So the next thing you'll notice is that we pass some runtime props. So if we go here to pet check-ins card, and let's say we add some runtime props. Let's say runtime props. Again, foo string, right? Okay. Now here, we're going to start seeing a type error because we expect to pass foo string, right? Now everything type checks. So that's kind of nice. So the way you should think about this is like you have a bunch of stuff that happens on the server, which is essentially everything inside of this Isograph query, literal, except like ignoring the client fields. That all happens on the server. And if you have some sort of state that only exists on the client, well, the only answer is to pass it via runtime props. And there's no way for a runtime prop to flow back into the server data. It's all server to client and never the reverse, obviously. Like that's like you're executing the query before you're executing the client code. So the way you would make something flow back is you would start another query. But like, we're not going to do that. Probably not going to do that during this hour. But just like conceptually, we have like some code that runs on the server, and that all flows down, and then you have access to both the server stuff and the client stuff. But anything that exists only on the client, well, it didn't come from the server. Okay. So let's take a look at what happens when we actually define a pet detail route. Okay. So the pet detail route will create something called, actually, let's take a look at a simpler one, because this one is, yeah, this one looks a little easier because it's a little simpler. Pet check-ins card, okay. And then we have resolver reader. Don't really worry about the names of these files. They're just generated files, and maybe they will make more sense at some point in time. But like the names are kind of silly. So we made the network request, we fetched all the data, and we wrote that into the, well, we wrote that into the Isograph store, which is something we haven't talked about yet. But it's cached somewhere. And then when we actually try to render this component, what we're going to do is we're going to take this Reader AST, and this is something that's generated, and we're going to traverse over this data structure and create the object that the pet check-ins card actually needs. So we're going to start with an empty object. We're going to encounter this thing here, and we're going to say, oh, it needs the ID. It needs the ID. It's not alias, so we're just going to call it ID. It doesn't need arguments. And so basically what we're doing is like object.id equals source data.id. And then we'll find check-ins, and we'll do something really similar for that, which is we'll create an empty object, and then we'll sort of recursively do stuff on that thing. Okay. So we have a data structure that we use at runtime to generate exactly the data that the pet check-ins card needs. So that's really nice, because it means that if in the pet detail route we start adding, what do we say, actual tagline or something like that? Is that what it was? Actual tagline does not exist. Whatever. We add some field here. Name. Okay, whatever. It has name. When we actually run the pet check-ins card, the data field doesn't change. We're actually getting just the fields that the pet check-ins card specifically requested. So that means you can make changes to other components, and you can't accidentally change the behavior of the pet check-ins card. So if you go here and we take a look at this, right? Let's find pet check-ins card. Yeah, pet check-ins data right here. Well, it has an ID and check-ins, nothing else. And the reason that happens is because we went ahead and used that Reader AST to generate exactly the data that's needed. Okay. So let's talk about what actually happens at runtime. Okay. Actually, before we do that, let's a little bit talk about an entry point. So this pet detail route entry point, it has the query text, but it also has another AST, a normalization AST. Excuse me. So the previous resolver reader, what do we say, pet check-ins card? Yeah. This guy, you noticed, it stopped at pet check-in display, which is a client field. And it doesn't contain everything within the pet check-ins display, because we don't really need that. Instead, but the entry point, on the other hand, it does. This entry point contains everything that's needed by this query text, or everything that's referenced by this query text. So in particular, like, there's no concept of client fields here. Everything sort of has been merged into a single query. So if we look at this thing, we might have a best friend relationship and best friend and blah, blah, blah. And this is part of one client field, but these check-ins are part of some other client field, and so on and so forth. Okay, so we have two ASTs, one for writing the network response back into the store, and then one for reading the data that's needed by a given component. And that's sort of those are sort of the basic uses of these ASTs. And these are, of course, generated by the Isograph compiler. Okay, so let's talk about what happens at runtime. Okay, so if we take a look at this, let's refresh. Okay, we make a network request. Again, these logs are like super disorganized, so sorry. It will be better at some point in time. Okay, so we start by making a network request. What happens is that when inside of here, yeah, when we have this use lazy reference, oh, again, this fragment reader is failing to compile because, or failing to type check because we added some runtime props. And I think it's like additional props, so maybe like foo, da da da. Hey, now it compiles. It's kind of nice to have that sort of end-to-end type safety. Okay, so what happens here in this regular React component here is that we call use lazy reference. Use lazy reference will, when it's initially rendered, make a network request for the data needed by an entry point, for that entry point's query text. And when that network request finishes, it will write that data into the Isograph store, the local cache, and it gives us a fragment reference. So we'll render it once, we'll get back a fragment reference. When we pass that fragment reference to fragment reader, we'll attempt to read the data. And then this will suspend because there's not enough data in the store during the initial render to succeed, to actually render out, to read out what we need. So this will suspend. This React suspense fallback here will render a full page loading fallback. And then when that network request completes, we will re-render this subtree right here. And when we re-render that subtree, we're going to re-render the fragment reader. And this time, we will successfully read out the data that is referenced by that fragment reference. And we will be able to actually render the page. So if we go here, again, doesn't like hot module reloading. So we take a look at what happens. Okay. So we make a network request. We're given this thingy. It makes a network request. And we get back a fragment reference. And we attempt to read it. And so done reading will give us back a response as kind missing data. Okay, so when we encounter this, that means that we're suspending. Well, when we encounter this, we will suspend. Okay, so at this point in time, we have read we've shown the fallback. And then we get the network response. So the network response contains some data here, which is what we saw. And then we normalize it into the store, which means we write it into the local cache. And after writing it to the local cache, what we're going to see is that this is what the local cache looks like. So every single item that has an ID in the network response becomes an entry in the thing. So this check-in 0, check-in 1, et cetera, et cetera, et cetera. Those are IDs that the backend gives us. 0.bestFriend relationship is not an ID the backend gives us. It's an ID that we've created on the front end. But those details, not extremely important. Okay. And oh, yeah. Okay, so the reason we have, okay, yeah. And all of these are here because they were somehow part of the network response, because we're just fetching initial data in this case. So these guys, these other pets, they come from this, they're used by this dropdown right here. Okay. So we've written the data into the store, like the specifics of that, not super important. And then we attempt to reread the tree. At this point in time, we're reading just sort of the outermost component, which is the pet stats card or something. Well, we get, okay, success. We get this data, right? We get a pet with a name and a bunch of other subcomponents. So remember, these subcomponents are stuff that you can directly render. So yes, they look like a component. They're like a function that React knows how to render. Okay, and then we finish that, and then we render the next child, which is this guy, like some sort of check-ins list here, and then we render another child, which is a specific check-in, and so on and so forth. Okay. So that's how the entire page is rendered. Okay. I'm going to pause here because that's sort of like the general gist of what Isograph does in order to make a network request for the minimal amount of data needed by a given page, and then to pass that data to subcomponents. Does that all roughly make sense? Okay.
Yeah, I did have a question or two that came up as you were going through stuff.
Sweet, let's do it.
So first question, is there like a skip parameter? So let's say we were waiting on an ID to go fetch pet info from some other network request, and that just hasn't resolved yet, but this component for whatever reason needs to render, can you like skip starting the isograph stuff while you wait for some other ID to get fetched?
Do you mean to say, okay, so the normalization AST, so the entry point, in the future, you will be able to say, do we have enough data to read this? Because that's that's essentially what we need. The entry point, you could crawl the Isograph cache to see, like, do we have all the data needed by this entry point? So yes, we will expose an API that says, like, given an entry point, is there enough data? And that's really important because if you navigate to a page and then back, well, that data is still in the cache, and so we don't want to make a network request because that's not there. So, because we already have that data, right? So we don't want to go to network twice. Right now, Isograph will go to network twice in that situation because it's just not an implemented feature yet. So yes, there will be APIs for checking whether you are able to render something without going to the network. But I think you were asking about something different. Is that right?
Yeah, I think so.
Okay.
If you could pull up just one of the components that we're passing ID into. So, the fragment reference area kind of is where that's what triggered it for me.
Yeah.
Or fragment reader. So let's say route.id, we're not getting it from the route, we're getting it from some network request. If that thing is undefined, but we still need like pet detail route loader to be loaded, could you pass in to use lazy reference, like skip when, bang ID? And so it knows, hey, we're waiting for this thing to be defined. It's undefined for now. Go, just hold on for a minute.
Yes, that will be possible. I'm not sure how we're going to do that, but yes. Being able to conditionally fetch stuff 100% is something that I want to do. And earlier we had talked about sort of CSS being part of this. Also, hi, Julio, welcome. Earlier we had talked about like CSS and other things being part of the query. And I sort of imagine that you would have something like, if ID is not equal to null, right? Something like this. I'm just making syntax up as I go, right? And that would be calculated. You would pass an ID, and if that's not null, well, then we would sort of traverse the rest of the tree. I'm not exactly sure how this would work. Like, really, what would be best is if Isograph was some sort of like imperative language that built up a query. It's not that right now, so like that's like a very long-term project. But yeah, something like that needs to happen, which is to say you need to be able to embed custom logic into your query to handle situations like this. Alternatively, in this situation, what we could do is render pet detail route loader conditionally, right, based on whether ID was present.
Yeah.
But like, yeah, we need the ability to have like more complicated logic embedded in the query. GraphQL itself is very limited in that regard because it just is very limited. So probably what the result will be is that Isograph will generate multiple queries, one like sort of per state, in order to generate valid GraphQL queries, but also allow you to encode the kind of logic that you really want. So yes, eventually, that will be supported. Okay. You said you had multiple questions or multiple things. Yeah.
The other one has escaped me, so I'll bring it up if I remember.
Okay, sweet. Okay, so the last thing we had talked about was that we get the data back, and then we sort of use these Reader ASTs to read out the data that's needed by a given component. Let's dive a little bit into what actually happens there. So, for example, if we take a look at this resolver reader, the pet check-ins card one, right? It has an array of things, one of which has a kind of scalar, one of which is a kind of linked, and then eventually we have this kind resolver, okay? So the way we actually do that is by going through read.ts, and this will call, let's just look for, oopsies, let's look for scalar. Why am I not finding scalar? Oh, because it's single quote, okay. Yeah. So eventually we will call this read data function. And that's what returns missing data if we don't have enough data, and otherwise returns success in various cases. Okay. Essentially what we're doing at this point in time is constructing the object that is passed to the child. Okay. So if we encounter a scalar field, well, what we're going to do is eventually call the target object and either the field.alias or the field.fieldName is equal to the value. And the value is the store record, which is the cached value, and we use whatever name we needed to get that value. And that name is a combination of the variables, their values, and the field name. Okay. And in a linked record case, well, what we're going to do is something really similar. Let's skip this array case. What we're going to do is this guy, we're going to call read data again with those sub-selections. So this linked field here has a bunch of selections, and we call read data again, so this eventually calls this guy, and we eventually call this. Okay, so the point is not specifically what are we doing in read. The point is to talk about resolvers. So resolvers here have two types. Again, could be modeled a little bit better, I think, but it has two types. One of which is a component reader artifact, and the other one is an eager reader artifact. So if we encounter the component reader artifact, what we're going to do is we're going to assign to the target, which is sort of the output object, a call to get or create cached component. So this guy is, let me see, component cache. This guy returns essentially a function here. And this function is the React component that is actually rendered. And this guy will read the data. We'll read the data and we'll call the function that we passed, or that we passed the ISO function, with passing it this first parameter, which again contains data and parameters, and it will also pass the additional runtime props as the second parameter. Okay, so what are we doing inside of component cache? We're doing two things. First is we are caching that component. So that means that between render to render, we are reading the same component. So these components have stable identity, which is important for React. If they didn't have stable identity, if we created the component anew every single time, well, then React would see this is a new function, and therefore it would like blow out all the state and remount the component every single time. So what we need to do is return a stable function. And that function is cached by ID, and then by the fragment name, and then by the serialized arguments, like the query arguments. These stringified args. And so, okay, so it's cached based on those things, and then it's stable. And then the second thing that it does is it will read the data that it needs inside of the actual component. So that means that if the component has missing data, that component itself can suspend. And so we can have, let's see, I don't know, React.suspend somewhere. We can do something like this. Let me see. This is the pet detail route, right? We have this suspense fallback for the entire thing. And then inside of this guy, we have pet detail for pet name right here. And then we have another suspense boundary for all of these stuff. So remember, this pet check-ins card will attempt to read the data that it needs only when it renders, and when it suspends, it will be caught by this suspense fallback with loading pet details. So in particular, if we go to the home page and then we make the network real slow, let's say delayed. Okay, so I'm going to refresh to make sure that I don't have any cache data. And what we do is we click on this guy. What you'll see is a loading pet details fallback, but we immediately loaded the title, the pet detail for Michaela title right here. And the reason we are able to do that is because when we read the root component, the pet detail route, we don't actually read the data for the pet check-ins card or the pet tagline card or whatever. Instead, we just read the data needed by that, and all those components, when we read them, well, they're just some function that exists. And if we render that component within a suspense fallback, we can get the behavior that we want, which is like when you navigate from a list view to a detail view, you can show sort of like the title and stuff like that immediately, but all the content can come in later. Okay. Yeah, I guess the point of that aside was that components are sort of read independently, but like all the other stuff is read out eagerly. So if we have something like a, let's say pet detail route, I don't know, let me say pet foo, right? And pet foo is not an at component, it's just a regular component. And then this guy makes name. Right, okay. Some random stuff like this. This should stop failing to type check if I didn't make any mistakes. Oh, I didn't make any mistakes, so it should stop failing to type check. Cool. It'll stop failing to type check. We're regenerating a bunch of files, and so sometimes TypeScript doesn't pick up on that, which is a bit of a bummer, but okay. So we get this, excuse me, sorry, my voice is going. So we get this pet foo, and inside of the pet detail route resolver reader, oopsies, pet detail route resolver reader, we have this pet foo, and this guy is a resolver, and the reader artifact here is an eager reader artifact. And if we go here and we take a look at eager reader artifact, well, we directly call missing data right here. And if that data is missing, well, then we return early and we suspend, essentially, at this point in time. So unlike a component client field, a regular client field, i.e. one defined without @component, will be read in advance. And that's because we need that value sort of directly accessible for the pet detail route function to make sense. Okay. There was something I was going to talk about next. Why don't I pause here and just say, did that little aside make sense? Okay, I see one yes. Feel free to let me know if it did not. Okay. Yes, the isograph.ts file. Okay, so how do we get static typing for this? If we look at name, we'll see that it has, if we go name, well, oh yeah, name dot name. Oh, name.data. Okay, sorry. This is actually like, I'm not even doing this correctly. It should be data and then parameters, right? But parameters does not exist. So it would be hello data.name. Okay. The reason that stuff worked is because you can stringify anything in JavaScript, and I wasn't being very careful. Okay, but this is now actually properly statically typed. We know that name is a string. How do we know that? The reason we know that is because when the Isograph compiler runs, it will generate an iso.ts file. So you notice right here, we're importing ISO from @ISO. And inside of the, I don't know, maybe it's Babel RC? No, not Babel RC. Next config. TS config. Yeah, there we go. TS config. We have this @ISO alias, which points to this iso.ts file. And that iso.ts file is generated. And so inside of this guy, we have some giant overload that says when we encounter ISO, when we encounter the ISO function that is passed any string that starts with white space followed by field check-in display, it will have this type. And in particular, it will be a function that takes this parameter. And so this is the parameter type that TypeScript understands. TypeScript will understand that this is the parameter type. And that's where all of the static typing comes from. So in particular, that's where we get the type of the data, and that's where we get the type of the parameters, which is what Vadim just landed, and super exciting. Okay. Okay. So that is how we get that the user gets type safety. Okay. The last thing I want to very briefly cover is loadable fields. Okay, so if we go back to that .dot file, remember we had talked about the blog body component being a separate network request, right? Because we want to defer it. The way that happens is with this @loadable annotation. Okay, let's say add item display. Okay, so if we take a look at, I don't know, newsfeed entry point, right? If we have it done regularly, you can ignore these type errors because obviously we're not doing the correct thing right now. We'll generate a query that inside of the add item selects the advertiser and the message. And that's what's used by add item display. Where is, I don't know where add item display is defined. We need a functioning VS Code extension so I can jump to definition. Okay, it's here. Okay, yeah, it selects the advertiser and the message. Okay, not very surprising. Okay, if we change this to be @loadable, well, all of a sudden, the generated query will not contain the data for that subtree, right? Now this add item here will just select the ID on the add item, and then instead, what happens is that what we get here when we what's past the add item display. If we can go here, we see that it is a loadable field. And a loadable field is essentially a wrapper around a function. And that function, when that will actually execute the network request for the data needed by the add item. Okay, so if it's a network request, it should have an entry point, and you are correct. Add item display wrapper, let's see, add item display entry point. Yeah. The generated query will be this thing right here. It's a node query that we refine to add item, and then we select, the ID, advertiser, and message. Okay, so as a result, when we go to newsfeed here, what you'll see is that when we paginate a few times, we're actually going to encounter an ad. Let me turn off this network delay. Okay, so we don't have an ad here, but if we scroll down, we do eventually find an ad. There we go. See, now we saw 2 GraphQL requests. The first one was for pagination. We got some additional items, newsfeed items 9 through 12. And one of those was an add item on which we just got the ID. And then we immediately made a follow-up network request for the data needed by that add. So it's whatever this stuff. It's this thing. Okay, so how does that actually work? So this add item display wrapper is given this at loadable. I mean, we put at loadable on add item display, and as a result, the add item display parameter is that loadable field, as we saw, and we pass that loadable field to use client side defer. Use client side defer is essentially, oh goodness, my headphones have just fallen off. Let me turn them back on. So use client side defer will is essentially use lazy reference. And in that, it will make that network request immediately when rendered and give us back a fragment reference. So one of the things we need to do is to unify those APIs. There's no reason that there's two redundant APIs, but like that's how it is right now. But essentially, yeah, it's just like another call to use lazy reference. And this guy will make a network request for that data, and then we pass it to fragment reader, and that will suspend while when there isn't enough data to read out the add item display, and then it will unsuspend when we'll reread the component will re-render when the network request comes back, and we will hopefully have enough data in the store at that point in time, and we will re-render and we will reread it. Okay, so there's two things you can do with loadable fields. So let's take a look at add item display wrapper, resolver reader, right? This guy will have a loadably selected field called add item display. And that contains an entry point. Well, an entry point contains a query text, so that's why it's basically the same API, just like with a different name, unfortunately. Okay. And yeah, another thing you can do with this is pass lazy load artifact true. And if you do this, well, now this loadably selected field contains an entry point, but it essentially contains an asynchronous import for that entry point, for the entry point JavaScript file. Why would we do this? Well, the normalization AST for something can be very, very big because it contains data about every single subcomponent, or I mean every single field that's used by that, right? And if you're not immediately loading a loadable field, well, you don't necessarily need to include that entry point with the parent bundle, right? So in this case, what happens is like when we refresh this, right? We're not rendering an add right now. There's no reason for us to include the JavaScript for that add. But if we paginate down a few times, well, now we fetch the JavaScript for the add, like basically for the entry point, and also the data for that entry point. So this is nice because we want to keep the parent bundle as small as possible. And the way that is achieved is by essentially the compiler will generate something that is an asynchronous import here. Okay. Why else would we do that? Well, we might do that if something is loaded in response to a user action. For example, like when a user clicks on a button to show a popover, we might want to load the entry point, etc., when the user hovers over that button or clicks that button or something like that. We might do that if something is very likely to be nullable. Well, we don't really need to load the video player field if very few blogs have a video player or have an associated video. So we might choose to do that if a field is nullable, and a variety of other cases. One of the things I would like to do is to sort of be able to, I don't know, make everything always asynchronously loaded, or at least like give you the option to do that in some way, or like maybe collect some analytics and suggest to you like, hey, this footer is not on screen during initial render, so maybe we should annotate it with @loadable. Yeah. Okay. So this use client side defer is one API that we have for immediately loading something, but then we have also like use imperative. I think it's use imperative loadable field, right? We have this blog item more detail field, which is also loaded with this @loadable annotation, and it's passed to use imperative loadable field. that gives us a load field function that when we click it, will fetch that data. So if we do that, click on load more content, yeah, we load the JavaScript, and then we make a network request for the data for it. That's all powered by sort of the same API. So is pagination. And yeah, what's nice about this is that it's sort of the same building block that's being used for refetching, for pagination, for loading stuff when something is not null, for loading something in response to user clicking, for deferring data, and so on and so forth. And that's going to be nice because we can generate sort of this tree, right? And we can do all sorts of fancy stuff, which we don't do yet. So for example, we might, like we discussed in that example.dot file, this blog body entry point, like it selects a body, and this blog, but like that field has already been fetched by the parent, so we remove it from the blog subquery. Like that's all possible because we're using the same primitive, which is sort of at loadable. Okay. That was a lot, I think, of sort of implementation details. I don't necessarily think that all of the specifics in terms of the syntax and stuff like that will be the same next year or whatever. Or, you know, as stuff changes. But like the rough outline, which is that we are traversing a tree and we're generating, you know, we're generating the query as high as possible so as to get good performance, but we want to make that query as small as possible for good performance. Like that is true. And the fact that we associate a function with its data is also something that I don't think is going to change about Isograph. So that allows us to do cool stuff like deferring the asynchronously loading the data and the JavaScript for a given component. Yeah, that's another thing that will probably never change. Yeah. Okay. I think that's what I wanted to cover. Okay. Anything else I should jump into or talk about, or anything that's unclear?
Just one question. Do we use the same store for client components cache and network response?
That is a really good question. The answer is not yet, because we should. There's no reason for us to. Okay, so one thing that we have with the client components, with the network response store, is we have garbage collection. So in particular, if you navigate, well, eventually, when an entry point is not referenced, is not mounted, it will be garbage collected, meaning anything that's only referenced by that entry point will be removed from the network response cache. Because, and the reason we want this is because we don't want the network response cache to, the memory usage of an Isograph app to grow without bound as the user just uses the app in different ways. We don't do that for the client component cache, but there's no reason that we can't store that in the network response store, because it's really just it's just an untyped store where we have to be very careful that what we're reading has the type that we expect. So eventually we want to do that. And eventually we want to cache a lot of other stuff in there too. So for example, we had that pet foo, right? This guy, remember when we went to read.ts and we found this eager reader artifact? Well, we did this, and then we called the resolver, so we called the pet foo function, and we calculated it every time. However, we know that the pet foo function, the value hasn't changed, because, I mean, at least you can, maybe the user has annotated pet foo as pure or something like that. But like by default, we expect that something only needs to be recalculated if its inputs have changed. So in particular, if the data that we read out here is different from the last time we read out that data, then we should recalculate pet foo. But right now on every render, we recalculate pet foo. So that's another thing that we should cache in the network response store. And again, that will give us sort of garbage collection for free and stuff like that. What else should we store in the network response store? Okay, glad you asked. Another thing that would be useful to store is, well, another reason that it is very useful to store stuff like this is because now these components can be stateful, which I haven't really fully thought out. But you can imagine that, like, because the pet foo is like stored at a specific location in the store, it might get a mutable ref passed to it or something like that, where it can just store whatever value it wants. And as a result, like, you can have something like, I mean, I don't know, you can store additional data in the store somehow, and it can be attached to a given node in a way that, like, that's kind of, you can't really do that right now. You can use component state if you're building components, but if you're building regular resolvers, which is regular client fields, which is the actual primitive, you can't really do that. Maybe you can store it externally in Redux, but like, we obviously don't want to force people to use Redux. And secondly, that has a lot of problems with stuff like, how do you enforce that something, how do you clean up after yourself? Well, Isograph is the only thing that knows how to clean up, knows when to clean something up. So, yeah. So they're basically the network response cache should be the everything store. And yeah, eventually everything will be cached in there. And that's going to make it a lot more efficient as well. Yeah. One thing that's nice about the client component cache right now is, and React, is that we can, well, okay, yeah. That will also give us better performance because we can just look at an item in the store and say, like, oh, this hasn't changed. Therefore, we can just reuse the cache value without doing a lot of extra checks. And the way we achieve that right now is by essentially storing the value that we read out from the store, from the network response cache, in state, and then setting up a subscription such that whenever the values in the store have actually changed, we maybe call set state again. And if we call set state again, so let's see, we go to component cache, we call use read and subscribe. This will call use re-render on change. This will call subscribe. And subscribe essentially gives us a, we'll call set encounter data and records whenever the data that we read out has actually changed. And so we will only re-render these components when their data when the fragment that they read out has actually changed. But that's kind of specifically tied to React. And we should do that for every single other one that isn't a React component. I think in the short term, most people will be using mostly @component client fields because you're building apps. So like what we have is like a very good initial step, but like eventually everything should be moved into the store and everything should be essentially invalidated whenever any dependency changes and so on and so forth. So, great question. Okay. If anybody has any other questions.
This one's more, long-term looking because right now Isograph's just React. What does the roadmap look like to get this to kind of a generic state? Do you regret like going all in on the React pieces? Like, why not write an internal class and then just decorate the React parts? Just curious where you're going with that. I don't have a reason to get off React anytime soon, but just the core of it would be very nice for any language, right?
Yes. I don't regret targeting React initially. I am a little bit neutral about targeting GraphQL initially. I think that the connections to GraphQL are a little bit more pernicious than the connections to React. With React, the connection to React is pretty light. In that, like, the Isograph store, like sort of the network response store, has nothing to do with React. I mean, maybe it has something to do with React because it knows how to handle @component style things, but like that's a very thin connection to React, and it would be easy to sub that out to have something that works with Svelte or whatever. So I'm not too concerned about the React part.
Okay.
With GraphQL, well, okay, so there's four ways that I want to make Isograph generic, if that makes any sense. One is I don't want it to be specific to React. Two is I don't want it to be specific to GraphQL. So in particular, we're generating a GraphQL query, but the user never sees GraphQL. So, and they write an Isograph fragment, and that an Isograph literal, and like that's not really GraphQL. There's a lot of stuff in there that, like, especially like that if syntax, like that isn't GraphQL. And it will diverge from GraphQL more and more as we go along. Thirdly, so for example, it'd be really nice to generate SQL or whatever, gRPC, whatever you need for your backend to do this kind of stuff. Yeah, tRPC as well. Okay, and then the next thing I want to be generic over is language. So the Isograph store is written in JavaScript, but it's pretty simple. It's basically like a cache of stuff that needs to be invalidated once in a while, and like there's a few core things that you need to be able to do, like go through an entry point, like traverse an entry point and see if see if we can fulfill it from cache. Read out the data for a Reader AST. Okay, like yes, that's doable in every language. So I want this to be something you can use multiple languages for. And that would also be really nice because eventually I want Isograph to sort of have a server component. So you might imagine that you have like this list of users that are attending an event. It's really nice to define that in your front end code base and just like see, oh, we get all the users and we filter out the ones that have blocked me. Okay. That's really convenient to just like define next to your component. And especially because an admin really should just be able to calculate that on the front end. You know what I mean? Like they already can see who blocks who. But if you're a regular user of of guild.host or something, you can't see who has blocked you. Or you're not allowed to see who has blocked you. So that really needs to be executed on the server. But it would be really nice to be able to co-locate that resolver or that client field next to your other components, just from like a simple mental model perspective. And once we start doing that and then forcing that execution to happen on the server, well, it kind of makes sense. Like, what if that resolver was written in a different language? Cool, it just kind of works. Okay, so probably the biggest Isograph roadmap thing is that eventually there will be a server component or something that like lives in front of your GraphQL API that does a lot of things like provide privacy or that kind of stuff. Or if you imagine a like this add item thing, right? Well, we're kicking off that request when the user when we render the subcomponent, right? That's pretty late in the game. It would be much better if we just started that network request on the backend as soon as possible. So like a server thing that understands, oh, we've encountered an add item that's not null. Let's like kick off that network request right off the bat and stream it to the client. Would be a lot more efficient than something that does this from the client, strictly from the client. So I imagine that anybody can use Isograph with only the client, and then upgrade essentially, or like get better performance by also installing something that lives on the backend and sits in front of their server. That logic that you talked about, like the if ID stuff, or even more complicated things, like maybe you have a union type, like a discriminated union parameter, right? Like either we're sending, okay, whatever, just stuff that GraphQL doesn't currently understand. Well, it would be a lot easier to just like send that data to the back end, and then have like something that lives in front of the back end do like, oh, okay, this needs to be broken up into 5 different consecutive queries to get the behavior that I want. Given that, let me like execute them like right on the server really fast, and then send that data down to the client. Because executing, like, if you break up a server because there's break up a query into like a bunch of subqueries from the front end, like that's not good for performance. But it should all be possible from the front end. Like everything should be possible from the front end, and then the stuff that makes sense to make more performant by having a server or having something that lives in front of your server on the back end is like a thing that will be on the roadmap. Okay, and then the last thing that I want Isograph to be generic over is the storage medium. So right now we have a like this Isograph, like the network response cache, which is very much a tree. But like you can sort of imagine that this read.ts file, like it can be used to read from an object that you read out from Redux. So you might have a situation where you're going from Redux and adopting Isograph. And you really like the Isograph user experience. Well, you really should be able to use that Reader AST to read from an object that is straight from Redux. Or if the object like, or if like the best friend relationship, right? Right now, remember we saw in the store, we saw this thing right here. After, I think it's like after normalization, yeah. We take a look at the store, which is the network response cache. We just have this zero.bestFriend relationship. That's like a separate item in the store, a separate key. But like, you may know statically that this best friend relationship is always part of this pet, right? Whoa, what just happened? Yeah, okay, right here, right? So it will, no other pet will reference that pet's best friend relationship, right? Okay, we might as well just like store that on the parent object rather than having another indirection. And that will be more performant because there's just one less indirection. So yeah, that's like the last thing that I want this to be sort of generic over. I don't regret going in on React because it's a small connection, and I think it will be fairly easy to make this work with Svelte or whatever. And it's probably going to be easier to make it work with Svelte or those other ones because they have proper constructors. And so like a lot of the complexity that we deal with in React is because, well, the component can render a bajillion times without ever committing. So we have to have some like an idea that we are caching. Yeah, I mean, we just have to have like a separate cache. Yeah. Julia, can you read that out? Because I don't see the whole thing. I don't see your whole message.
Yeah, sure. I was just thinking out about the different outputs, like you mentioned, and I think I don't know the current structure, how it is today, but one thing that comes in mind is that use a plugin-like architecture where you have a core functionality, and if you decide to use TRPC, you just plug a TRPC plugin. If you want to use a REST API, just plug in a REST plugin, and so on. So, and also plugins have the ability to be, if the intent is to enable in the future, community members can also contribute to it. So it has all those benefits. It's just a suggestion.
Yeah, that's exactly where I want to go. Right now, like React is sort of like part of Isograph, but like it should be something that like there should be a core Isograph, and then there should be something that like, and there should be a version with Isograph. And so in particular, I'm thinking like if we have something like blog body component, I don't know, let's say blog header component. Blog header component uses React, right? Like, right? So then this blog entry point you know, like Isograph React stuff, right? So like, because we use React somewhere in this tree, right? Here, as a result, we want this entry point to like include the React stuff. And I think of, you know, I think of it as like there is a core, and then based on what we actually encounter you using, we would generate a different Isograph library or something like that. Yeah, that's exactly what I want.
Since you are checking what the user is using, maybe it's overcomplicating, but it can end up being like the Astor framework, where there is the island concept. You can actually use wherever framework you want, and it just handles whenever needed. But for me, it's just overcomplicating.
I mean, you're
But
probably right that most people won't, but like, yeah, you should be able to intermix React and Svelte components in the same tree, and it should just work. Maybe you have to
yes,
have some sort of like, you know, like call to React DOM.render or whatever, but like by and large, yeah, I would imagine that you should be able to intermix stuff in a tree, and it should be easy to do migrations incrementally and stuff like that.
yeah.
Yeah. Yeah, I guess like another thing. Okay, so you're talking about roadmap. Another thing that I want is, well, obviously the VS Code extension will be really important to be able to go from an isograph literal to jump to definition and stuff like that. But also you imagine that like this, what we're looking at right now, is something that should be generatable from the code, right? So we should have some sort of like visualizer. And then you should be able to look at this and be like, oh, I want to click on the blog header and be like, I also want the author, or I want the email, or whatever. And it should just like kind of like make the changes. And you should be able to have some sort of like UI where you see like, oh, I'm on a blog, so here are the components that are available. So the easy version of that, I imagine, is that we generate a GraphQL schema extension that Graphical can understand. So at least when you're on Graphical or OneGraph or whatever, like one of those other query generators, you'll see like, oh, on the blog header, or I mean on the blog, we have a blog header and we have a blog body. And so people will not define like 50 different versions of that user avatar, or like inline like all this kind of stuff, and lead to like styling inconsistencies. But there is a canonical thing called a blog title, and you should use that, and it's always like suggested to you. And yeah, I like imagine that like basically the code is one way to view things, and then there's a graphical way to view things that is very useful. I mean, that is more amenable, more approachable for people who aren't like IDE users on a day-to-day basis. Maybe they're just like trying to build an internal UI, and like so they can easily do a click and drag kind of thing. And it would be nice to be able to look at that and like click on an edge here and say make this loadable, and like, you know, have it kind of do that change for you. Yeah, that's like the big, yeah, that's like that's some of the big stuff that's on the roadmap. Well, in my mind, is on the roadmap. So go for it.
Is there kind of a benchmark with the current implementation compared to the others?
Nope. Eventually, that's also on the roadmap. Yeah, we should. Yeah.
Because, for example, if someone is interested to Isograph, but I think the most direct way to prove it's worth it or not is like putting in the land page, hey, our performs X second and theirs performs in X second, Y seconds, something like that. Like Fastify promotes, Hono promotes their routes. There's
Yeah,
their
I think eventually that would be good. I imagine that most of the benchmarks are not well suited to Isograph because, like, one, I mean, most of them are just like doing initial renders and stuff like that, right? But like, Isograph will really shine with respect to making incremental changes to your responding to incremental changes and re-rendering just the components necessary, and it should be extremely snappy in that sense. Um, and it should also it has like a developer experience win, which is like generating the queries automatically and stuff like that. And like for most benchmarks, like they're kind of small, and in a small world, like you can manually do everything you need, and it's not really a big deal. But yes, 100% we need benchmarks, and the kind of benchmark I would imagine where Isograph would be really good is like a really complicated app, pagination in a complicated app, like where you're starting to see like hundreds or thousands of components on the same page, or things like that. But yeah, I'm not sure if we're. But yeah, like there's missing features right now, so like I'm not exactly searching for thousands of new users quite yet. Biggest
it's
features are
just
like mutations related.
I was just thinking how to promote it over the others.
Yeah. But yeah, we eventually need that. So okay, awesome. I'm gonna stop the recording now. For those on YouTube, thank you so much for coming, and we will record more of these that will dive into different parts of the Isograph codebase. In particular, I want to do one soon about specifically uh, how the compiler works. And presumably there's a lot more like specifics of how the runtime works, but hopefully this one will serve as sort of a why Isograph big picture uh, big picture thing until we record something more proper and more with more time investment and stuff like that. Okay.